Yo, yo, yo.
What is up?
What is up, friends?
I don't know how to respond to that.
Yeah, I didn't. Okay. We're working on our on fleek outfits, right? Mm-hmm.
Yes.
So we have our bling,
Bling, bling.
yes, and our sweet hats.
Or cap?
Cap?
No,
Ooh,
I don't know.
I don't either. Okay,
Hat.
so we're here to talk about empirical formulas, but we figured it be in the theme of rappers.
Mm-hmm. Yes.
Yeah, because there's a rap for you to remember how to do this.
Yes,
yeah,
I don't know the rap, but okay.
Okay, so we'll start with what is an empirical formula, okay? Well, it's the smallest whole number ratio of a formula.
Okay, sounds
Okay,
good. Makes sense.
It's the smallest amount you can make.
Like NaCl
Right.
is the smallest whole number ratio. One Na,
one Na, one Cl, yeah.
Cool.
Okay, so like for example, we have sugar.
Ooh, love
okay.
It. Yeah, a little glucose,
C6H12O6.
Mm-hmm.
However, if you look, you can divide all those by 6.
You could. Yes.
Right. So it's a really large formula, but we can talk about it being reduced to just like 1 carbon, 2 hydrogens, and oxygen. That's the ratio of
So I just take the formula and I reduce it. If it can't be reduced, then it's the empirical formula.
Absolutely.
Nice and easy. Okay.
Nice and easy. So, how do you figure that out? Well, here's our little rap.
Ooh.
Can you throw me a beat? You're really bad at this. So it goes percent to mass, mass to mole, divide by small, times to whole. Got that?
Yeah.
Okay.
Got it.
So we're going to do this little rap, and that's how we can get through each one of these problems.
Okay.
Okay?
Mm-hmm.
So the first thing we do is we got to convert our problem from percent to mass. So
Gotcha.
I'm just going to take the percents and turn them into masses.
Okay. So this works because I can assume a 100-gram sample, and so 39.9% of 100 grams is 39. Yeah, the math's important.
Yes.
They like the math.
I know they do like the math. So we're just going to assume that it's a 100-gram sample.
Yeah.
See, look at that. You were ahead of the game.
Oof.
I mean, you were so with it.
Merch.
Yes.
No,
that's what they say.
I know, but your response is it's already been merged.
It's already been merged.
Which I still don't understand.
I don't really know what merged means. Okay. We'll work on it.
Yeah.
Okay. So step 1, done. The percent to mass, we can put a check by it. Okay.
Man.
Yeah. We're
You're almost as good as Vanilla Ice.
The bling. Okay. So the next step is to go from mass to mole. Well, that's easy. We've been doing that. Yeah, so we take each one of our masses, we divide it by its molar mass.
Love it.
Okay.
Oh, it's like we taught you something for a reason that you'll use later on.
Exactly.
Oh, I love it when it ties in.
Mm-hmm. Now, there's one thing we do want to point out here is that you don't worry about the diatomics in this case. We're not taking that into account, so it's plain old molar mass of whatever you're working with.
Got it, yes.
Okay, so I went from percent to mass by just changing the percent to a G.
Yep.
And now I'm going from mass to mole, so we can put a little check for that one.
Boom. Okay. Halfway done-ish.
Woo-hoo. And then we can move to now divide by small.
Small being the smallest number?
Right. So when you look at the 3 answers we got, 3.32 was the smallest number.
Yep.
Okay, so I divide each one of them by the smallest number, which gives me 1, 2, and 1. Okay. 1, 2,
so
1.
If they're off by a little bit, we just round to the nearest whole number, right?
Yeah. Well, and we're going to do an example where they're not as easy as this.
Ooh.
Mm-hmm. Okay.
Love it.
So, there it is. Okay. The times till whole
run down
part.
that little beat.
Whoop. Yeah, it was a beat.
Little scratching.
Whoop. Okay, that was terrible. All right. So times till whole we don't have to do because they're already whole numbers. So our formula in this case would be 1C, 2 H's, and an O. That would be our empirical formula.
How would I times till whole?
Well, for example, if it was like one of our problems said 1.5, we would times it by 2 to get it to 3.
Gotcha.
Okay.
I would just scale everything up
to get a whole number. Yeah.
Okay.
And that's going to be this next one.
I'm waiting.
Okay. All right. So we're going to combine these. So we're going to do 2 steps at one time.
Okay.
Make it a little quicker here. So percent to mass. Boom, here's our compound. We got 72% grams magnesium, 27.8 grams of nitrogen. So, percent to mass,
done.
Check. Just switch it.
Nice and easy.
Yeah. What's the next part of the rap?
Percent to mass, mass to mole. Oh, so it's got to be mass to mole.
Mm-hmm.
I hate that works so well.
The rap?
Yes, I hate myself for having to do that.
I know, it's pretty cool.
Oh, I hate you.
Okay, so we got mass to mole. So now we have our 2 moles amount. Okay. Now it's divide by small. You got to get the hand motions. So the smallest one is 1.99. Okay, so here's our example.
Okay.
So we got a whole number for one, but we got a 1.49.
Okay, so we divided by 1.99 for both of them. We got 1.45. We got 1. Okay, so now I need to times till whole.
Times to whole. So we're going to times 1.49 by 2 to get it to whole, as close as whole as possible.
Okay.
So, well, that's close enough. We're just around a 3.
Yeah.
But what we do to one, we have to do the other.
Got to. Yeah.
Okay.
It's like balancing kind of almost.
Yeah. So we have our magnesium count then is 3, and our nitrogen is 2. So our formula would be Mg3N2. Pretty simple, right?
Yeah, that's not bad.
Okay.
Seems pretty straightforward.
Yeah. Well, we got to catch our...
Right? Yeah, I don't know what the term for catch our kicks.
Kicks. We got to get our kicks on the rope.
I feel like that's a commercial.
Okay, we're gonna have to work on that. All right, we're gonna go work on that. We'll see you in class.
Bye.
Bye.